Our paper focuses on the efficient query selection. As we know, to obtain impressive classification performance, a classifier has to be trained based on a large number of library instances. However, collecting this instance is generally a costly project. To address this issue, active learning is therefore preferred, which reduces the above efforts by labeling a few high-quality queries. Acceptor error reduction is the most popular active learning criteria, which generally works with an efficient classifier. ER makes a trade-off on the error reduction achieved by either labeling an unknown region or tuning distribution boundaries. However, ER-based methods contain huge costs from both the classifier retraining and the label reinference. To reduce the above cost, there are two alternative active learning criteria, including uncertainty-based sampling and the maximize model change. Different from the ER, the methods based on the uncertainty need no assumption on the labels of candidates and are highly efficient. They perform well at tuning distribution boundaries. However, as the uncertainty is evaluated for each candidate independently, these methods are unable to consider the impact of possible labels on the classifier, as well as the accuracy improvement on other instances. Another kind of methods is based on maximized model training. Compared with ER, these methods do not require the label reinference for a vast instance, and remarkably reduce time costs. On the other hand, compared with uncertainty-based sampling, they do consider the impact of labels on the classifier and perform better at discovering new classes. However, as they still ignore the impact of labels on real instances, their performance are insufficiently well with the number of labels increase. Therefore, it is supposed to avoid the label reinference and combine the advantages of the above two criteria. Our paper proposed a novel active learning criteria called Approximated error reduction. The objective function is built up on the framework of the error reduction and can be simplified to the one based on the local uncertainty of each candidate and its impact on the other instance. As a result, apart from the similar time cost to that of the uncertainty-based sampling, the remaining cost of our approach is independent of the data size. Here is an example on classification task. As we can see, compared with ER, the method based on our AER obtains a high accuracy with less time cost. More experiments and details can be found in our paper. Thanks for your listening.